In this video, we're going to have a look at diodes. A diode is a component that allows current to only go in one direction. There's a stack of different types of diodes, and to go with the different types of diodes, there's a stack of different symbols. But just know that if you're looking at a triangle thingy, it's probably a diode. I thought I'd do this introduction video using two types of diodes, power diodes and light emitting diodes. This is a power diode, and this is the symbol for a general power diode. Diodes are polarized, and that means it's got a positive and a negative. You can look at the symbol and see which way is negative, because if you look at the triangle, it actually looks like an arrow, and you can imagine that the arrow is pointing to this little bar, and that's the negative symbol on its side. So this is an easy way to remember. This side is negative, and that side is positive. This is a diode. It's a through-hole component, and you can see there's a little bar that goes the whole way around the diode here. That stripe is telling us that that is the negative side of the diode. A power diode on its own, when it's allowing current to flow through it, has nearly no resistance on its own. And Ohm's law says that if there's nearly no resistance, then all the available current will try and flow through this. Here's what that looks like. So to stop that happening, I'm going to put a 1 kilo ohm resistor in series. And this is just to stop or slow the amount of current going through the diode. I've got out my trusty unregulated power supply, and I've set it to 12 volts AC. On the oscilloscope here, you can see what that waveform looks like. But watch what happens when we put in our diode. This is interesting. All the negative part of our AC is being snipped off. Technically, this is actually DC now. If we have a closer look and overlay our AC and our DC waveforms, we can see that the diode has done something. The diode doesn't do its dioding for free, and so you can see there's a small voltage drop across that diode. In case you're wondering, that difference in power is mostly going to be transferred to heat. So the more current and the higher the voltage that's going through this diode is going to make it heat up. So it can be a little bit tricky sometimes to match the diode that you need for your situation. That voltage drop could matter to your circuit. The maximum voltage could matter to your circuit. The maximum current going through your diode could matter to the type of diode you select. The physical shape of that diode could matter. So I hope you're getting the idea that the diode family, just like the resistor family and all the other families of components, is a large one. Let's have a look at LEDs. This is the symbol for an LED. See how it's subtly different to the symbol for a general LED. Light emitting diodes are very similar to power diodes. They're just not as powerful. That is to say, you can't pass as much power through an LED. They're only rated for a small amount of current compared to a power diode. Just like a power diode, you really need to put some resistance in series with the diode to limit the amount of current going through it. LEDs are super useful to use as an indicator to us people to see what the circuit is doing. Just like a power diode, they can only allow current to go one way. So if you allow too much current to go through your LED, maybe you've selected a resistor that's too small, this can happen. It may not break spectacularly like this. You may only shorten its life. At 5 volts for a general purpose LED, you need to put a resistor that's about 330 ohms in series for the LED to work at its brightest. If you use less resistance than that, then the LED may glow a little bit brighter, but eventually you're going to break it because too much current is flowing through it. If you add more resistance in series to that LED, well, the LED will glow less brightly, but it won't damage it, and that's because there's less current going through that LED.